A fruitful and nutritious day, developers. This is Eat Well. Embrace a tasty and well-balanced eating lifestyle. This project is for CS 121, Advanced Computer Programming, and is developed by NutriGuild of CS 1202. This project aimed to create a personalized nutrition and meal planning system that offers customized nutrition plans and meal recommendations based on individual health goals and dietary preferences. The system's objective is to assist users in making healthier food choices and enhancing their overall health and well-being.
In the Login tab, user can choose to log in, sign up, or exit the program. New users can select the sign up option to create their profile. They will be asked to enter their username, password, age, weight, height, and sex. The entered data will be stored in the users.txt file and will be include the basal metabolic rate or BMR and initial water intake. Existing user can log in to access the main program or the main tab.
In the User Info option, or Option 1, users enter their username. They are presented with two options, View Info and Exit. If they choose to view their info, their personal information is displayed. Users can update their information individually, and the changes are automatically saved.
Option 2 allows users to request a random recipe. The recipe in this mode are limited because the system selects randomly from a pre-created list. The recipe includes a set of ingredients and brief nutritional facts.
Option 3 asks user if they want a grocery list for a specific meal. If they choose option 1, they are prompted to select a meal for which they want a grocery list. With the assistance of AI or the artificial intelligence, the system automatically generates the list in bullet point format.
Option 4 offers 5 modes: goal setting, track calories, check progress, and reset tracker. In the goal setting mode, the user's BMR is displayed under data. Track calories allows user to enter the amount of calories consumed. Check progress monitors the remaining calories that need to be consumed. Reset tracker restores the target calories or BMR to its default value.
Option 5 tracks the user's water intake. It includes track water intake, check progress, check goal achievement, and reset tracker. Track water intake prompts users to enter the amount of water consumed. The entered amount is compared to the required water intake per day, which is 1,896 ml in the check progress section. Check goal achievement displays the remaining amount of water that needs to be consumed on a particular day. Reset tracker allows users to reset the target water intake.
The last option enables user to input the food they consume on a particular date. This mode has two options. First, record food and the food diary. In record food, users enter the date in the format month, day, and year. If the users enter the wrong sequence, an error message is displayed and allowing them to correct the input date. Next, if user choose between breakfast, lunch, snack, or dinner and input the corresponding food items, the food diary option displays the entered data and allowing users to delete specific items from the list and save the changes.
Class user and class registered user. These are class definitions for user and registered user. The user class represents a basic user with a username and password. It has an authenticate method that checks if the entered password matches the user password. The registered user class inherits from the user class and adds additional attributes like age, weight, height, sex, and BMR. It also has a display info method to print the username. Define calculate BMR. This function calculates the BMR on the user's age, weight, height, and sex as parameters. Depending on sex, M for male, F for female, it uses different formulas to calculate the BMR. The calculated BMR value is rounded to 2 decimal places and returned. Define save user data, def save BMR, and def save water. These functions are responsible for saving user data, BMR, and water intake to separate text files. Save user data takes a list of users as input and writes their information to a file named users.txt. Save BMR appends a user's username and BMR to a file named calorie.txt. Save water appends a user's name and water intake initialized as 0 to a file named water.txt. Define load user data. This function reads user data from the user's.txt file and returns as a list registered user object. It opens the file, read each line, splits the line into fields using the colon delimiter, and creates registered user object using the extracted file. The registered users objects are appended to a list. Additionally, it calls save BMR and save water to save BMR and water intake for each user. Finally, it returns the list of registered user. Define login. This function handles the login or sign up process. It first calls load user data to retrieve the registered user's information. Then it displays a menu with options for logging in, signing up, or exiting. If the user chooses to log in, it prompts for a username and password. If a matching user is found, it calls the authenticate method to validate the password. If the password is incorrect, it executes the main menu.python file. It calculates the BMR based on the provided information and creates a new registered user object. The user's data is then saved using the save underscore user underscore data, save underscore BMR, and save underscore water function. If the user chooses to exit, it breaks the loop and ends the program. If an invalid choice is entered, it displays an error message. Overall, the code provides a user authentication system with login and sign-up functionality. It uses inheritance to extend the basic user class and stores user data, BMR, and water. Import statements. The code imports several modules like time, choice 1, choice 2, choice 3, choice 4, choice 5, and choice 6. These modules likely contain specific functionalities related to the choices presented in the menu. Variable assignments. Several variables like Nutri1 up to Nutri6 are assigned the values of choice 1 to choice 6 respectively. These variables likely represents instances or objects that provide functionality related to the different choices in the menu. While loop. The code enters a infinite while loop which repeatedly displays the menu and prompts the user for their choice. The loop continues until the user chooses to log out or select Save Menu Display. Inside the loop, the code displays a menu using several print statements. The menu provides options for different functionalities. The menu is visually separated by lines of equal characters. User input and functionality execution. The code prompts the user to enter their choice by using the input function. Based on the user's input, the code executes the corresponding functionality related to the selected choice. Each choice is handled with an if statement. Overall, the code represents menu-based system where the users can select different options to access various functionalities related to user info, recipe suggestion, meal planning, calorie tracking, water intake tracking, and food diary. The specific functionality associated with each choice implemented in separate modules, choice 1 to choice 6. The code uses a while loop to repeatedly display the menu and execute the chosen functionality until the user chooses to log out. Choice 1. User info. Function calculate BMR. Calculates the BMR based on age, weight, height, and sex. Uses the Mifflin-St. Jean equation for males if sex is M and females if sex is F. Returns the rounded BMR value. Returns 0 if sex is neither M nor F. Function ViewInfo. Retrieves user information from users.txt using the provided username. Prints the user information including username, password, age, weight, height, and sex. Calculate and prints the user's BMI using the calculate BMR function. Returns true if the user is found, otherwise print user not found and returns false. Function update info. Allows the user to update their information based on the provided username. Prompts the user to enter updated information, username, password, age, weight, height, and sex. Validates input for age, weight, height, and sex. Calculate the updated BMR using the calculate BMR function. Writes the updated data to users.txt and calls update calorie file. Update calorie file. Updates calorie.txt based on the information in users.txt. Read users data from users.txt and extracts username and BMR. Write the updated user data to calorie.txt. User info. Handles the user information functionality. Displays a menu for entering the username and choosing options. Prompt the user for username and shows a submenu View Info or Exit. Option 1 is chosen, calls View Info and provide username. If the user is found, prompts for updating info or exiting. If option 2 is chosen, calls update info with the provided username. Provides option to go back or exit. The execution, if the file is run directly, calls the user info function to start the user information functionality. The code implements a user information system allowing users to view and update their personal information. It relies on the files for data storage and provides a menu-based interface for user interaction.
The first part is a script that allows the user to get recipe suggestions and nutritional information. It contains a while loop that keeps the script running until the user chooses to exit. Within the loop, the user is prompted to choose whether they want a recipe suggestion or to exit. If the user chooses to get a recipe suggestion, the suggested recipe function is called. If the user chooses to exit, the loop breaks and the script terminates. The second part is a module that defines classes for recipes and stored recipes. It also includes a list of stored recipes with their ingredients and nutritional facts. Here's a breakdown of the classes and their methods. Recipe class. This class represents a single recipe. It has 3 attributes: its name, ingredients, and nutritional facts. Init method initializes the recipe object with the provided name, ingredients, and nutritional facts. str method returns a string representation of the recipe object. Stored recipe class. This class represents a collection of stored recipes. It has 1 attribute, which is only recipe, a list of recipe in objects. Init method initializes the stored recipe object by creating recipe objects for each recipe in the provided list and appending them to the recipe list. Random recipe method returns a random recipe from the recipes list using the random.choice function from the random module. Recipes list. This list contains dictionaries representing different recipes. Each dictionary has keys for recipe, the name of the recipe, ingredients, a list of the ingredients, and nutritional facts, a dictionary of nutritional facts. The code is designed to provide a simple recipe suggestion system. The user can choose to get a recipe suggestion, and the system will randomly select a recipe from the stored recipes and display its name. The user can then explore the suggested recipe further if desired.
Choice 3. Meal planning and grocery list creation. First, import the OpenAI module for interacting with the OpenAI API. Define the getAPI key function to read and return the API key from API.txt. Define the meal planning function to handle the main logic. Set API key using OpenAI.API key is equal to getAPI key inside the meal planning function. And then start the indefinite while loop. After that, display a menu to the user. Read the user's choice from input to store it in user choice. If the user chooses to get a grocery list, it will display a grocery list menu. Prompt the user to enter their meal and store it in message. If the user enter quit, break the inner loop, and the user's input to messages as user message. Call the OpenAI API to generate response using OpenAI.chatCompletion.create. Extract the assistant's reply and store it in reply. Append the assistant to reply message as an assistant message. Print the assistant's reply. Break the inner loop. If the user chooses to exit, break the loop and terminate the program. If the user enters invalid choice, display an error message and continue the loop. In the main block, execute meal planning function when the script is run. Directly, the program uses OpenAI API and requires API keys stored in API.txt.
This code defines a calorie tracker class and several helper functions to track and manage calorie goals. Let's break it down step by step. Number 1. The code begins by defining a class called Calorie Tracker. This class has the following methods: init with the parameters self and goal. This is the constructor method that initializes the calorie tracker object with a calorie goal and sets the total number of calories consumed to 0. Track calories with the parameters self and calories. This method takes the number of calories consumed as input and updates the total calories attribute of the calorie tracker object by adding the consumed calories. Check progress. This method calculates the remaining calories to reach the goal and prints a message indicating the progress. If the remaining calories are greater than 0, it displays how many calories are left. If the remaining calories are 0, it displays a congratulations message. If the remaining calories are negative or excess calories, it displays how many calories have been exceeded. Reset tracker. This method resets the total calories attribute of the calorie tracker object back to 0 and prints a message indicating that the tracker has been reset. Set goal with the parameters self and goal. This method allows updating the calorie goal of the calorie tracker object and prints a message indicating that the goal has been set. Number 2. Following the class definition, there are 4 helper functions defined. Get BMR from file of username. This function reads a file named users.txt line by line and extract the basal metabolic rate or BMR value associated with a given username. It returns the BMR as a float. If the username is not found, it returns none. Get progress from file of username. This function reads a file named calorie.txt line by line and retrieves the progress value associated with a given username. It returns the progress as a float. If the username is not found, it returns none. Save progress with the parameter username and progress. This function appends the username and progress values to a file named calorie.txt in the format username progress. Main. This is the main function that handles the execution of the calorie tracking program. It interacts with the user through a command line interface. Number 3. Inside the main function, the program displays a welcome message and enters a while loop that repeats until the user enters a valid username or chooses to exit. Number 4. Within the loop, the user is prompted to enter their username. The program calls the getBMRFromFile with the parameter username function to retrieve the user's BMR. If the username is not found, an error message is displayed and the loop continues. Number 5. If the username is found, a calorie tracker object is created with the retrieved BMR value. A Boolean variable update BMR is set to false. Number 6. Another while loop begins to display the main menu of options for the user. The user can choose between goal setting, tracking calories, checking progress, resetting the tracker, or exiting the program. Number 7. Based on the user's choice, the program performs different actions. If the choice is 1, the current goal is displayed. If the choice is 2, the user is prompted to enter the number of calories consumed, and the track calories with the parameter calories method is called to update the calorie count. If the choice is 3, the check progress method is called to display the progress and retrieve the progress value from the file. Using get progress from file of username. If the choice is 4, the reset tracker method is called to reset the calorie count. If the choice is 5, the program checks if the update BMR variable is true, meaning the calorie count has been updated during the session. If so, it calls the save progress method with the parameter username and BMR minus tracker.total calories function to save the remaining progress in file. Finally, the loop is broken and the program terminates. Number 8. If the user enters an invalid choice, an error message is displayed and the loop continues. Number 9. Once the inner loop is exited, the outer loop is also broken and the program terminates. Number 10. The if name equals main block ensures that the main function is executed only if the script is run directly, not when imported as a module. In summary, this code allows users to track their calorie consumption, set goals, and check their progress using a command line interface. The progress and goals are stored in files, and the program uses a calorie tracker object to handle the tracking and management of calories.
The code begins by defining a class called Water Tracker. This class has the following methods. Init. This is the constructor method that initializes the water tracker object with a water intake goal and sets the total amount of water consumed to 0. Track water. This method takes the amount of water consumed as input and updates of the total water attribute of the water tracker object by adding the consumed amount. Check progress. This method prints the total amount of water consumed and the goal value, fixed at 1896 ml in this code. Check goal achievement. This method checks if the total amount of water consumed is greater than or equal to the goal. If it is, it prints a congratulations message. Otherwise, it calculates the remaining water needed to reach the goal and prints a message indicating the remaining amount. Reset tracker. This method resets the total water attribute of the water tracker object back to 0 and prints a message indicating that the tracker has been reset. Following the class definition, there are two helper functions defined. Get progress from file. These functions read the file named water.txt line by line and retrieves the progress value associated with the given username. It returns the progress as a float. If the username is not found, it returns none. Save progress. This function appends the username and progress values to a file named water.txt in the format username progress. The main function handles the execution of water intake tracking program. It interacts with the user through a command line interface. Fourth, inside the main function, the program displays a welcome message and enters a while loop that repeats until the user enters a valid username or chooses to exit. Fifth, within the loop, the user is prompted to enter the username. A water tracker is object created with the water intake goal set to 1896 ml. A Boolean variable update progress is set to false. Sixth, another while loop begins to display to the main menu of options for the user. The user can choose to track water intake, check progress, check goal achievement, reset tracker, or exit the program. Based on the user's choice, the program performs different actions. Track water amount method is called to update the total water intake. Check progress method is called to display the total water consumed. Check goal achievement method is called to check if the goal has been achieved. Reset tracker method is called to reset the total water intake. Update progress variable true, meaning the water intake has been updated during the session. If so, it calls the save progress function to save the total water intake in the file. Finally, the loop is broken and the program terminates. If the user enters an invalid choice, an error message is displayed and the loop continues. In summary, this code allows users to track their water intake, check progress, and set goals using a command line interface. The progress and goals are stored in file, and the program uses a water tracker object to handle the tracking and management of water intake.
This code implements a simple food diary application using the food diary class. Here's a step-by-step explanation. The code begins by importing the datetime module. The food diary class is defined, representing the food diary functionality. The init method initializes three empty lists: date, meal, and food. This list will store the recorded food entries. The record food method allows the user to record their food intake. It prompts the user to enter the date in the format month, day, and year, and validates the input using a try except block. If the format is incorrect, an error message is displayed. After validating the date, the user is prompted to enter the meal type, which must be one of breakfast, lunch, dinner, or snack. If an invalid input is provided, an error message is displayed. The user is then asked to enter the food they consumed. The recorded data is appended to the respective list. The view diary method allows the user to view the contents of the food diary. It reads the content of the food diary, the text file, and prints it to the console. Then, the user is given the option to delete entries. If the user chooses to delete an entry, they are prompted to enter the data they want to delete. The file is read line by line, and if a line contains the specified data, it is skipped during writing, effectively deleting the entry. If the specified data is not found, an appropriate message is displayed. The diary method is the main loop of the program. It represents the user with the options to record food, view diary, or exit the program. Based on the user's choice, it calls the respective methods. Finally, the name is equal to main block creates an instance of the food diary class and calls the diary method to start the food diary application. In summary, this code allows users to record their food intake, view their food diary, and delete entries if desired. The recorded entries are stored in a file, and the program uses the food diary class to manage the diary functionality.